set it up this way. I just
I got don't even worry.
Anyway, so yeah, welcome to Game Development Club. I already said all the introductory stuff already, so yeah, thanks. So a video game at its like very, very basic level is just a collection of files. You have stuff like music files and sprites, like 2D images, 3D models, sound effects, all that kind of thing. And usually it's a lot easier to make that stuff using software, so you got like 2D art programs for making sprites and animations and things like that. You've got music programs, a lot of really handy-dandy stuff, and we'll get into all that. Really important files are script files and scene files, which is like your actual code that you write as a game developer. And that has to do with a piece of software called a game engine. Game engines are really important and useful, as you'll see in a bit here. So there's a lot of software that you can use, but don't really need to use. So if you're making a 2D game, I recommend Krita. It's a 2D art program. You just install it, you can draw stuff, you can make animations. It's got a lot of options for that kind of thing.
It's free and open source.
Free and open source, thank you. The only thing on this list that is not open source is Unity, and Ableton Live. And Ableton Live is not free either. There's a lot of good options, though, for music if you don't want to use that. This is just what I personally use. Like I said, game engines, very important. This is like the thing you need to start with. I personally recommend Godot. If you want to get started making a video game, like if you're questioning, how do I get started in game development, download Godot. We've got links to that in our Discord channel. Easiest way to start. So, why use a game engine? Well, there's a lot of code that every video game kind of shares, such as like user interface or accepting input from the fucking keyboard to the program itself, or input detection, physics systems, stuff that would be incredibly time consuming if you tried to write it yourself, but a lot of games share. And so programs exist for that. Again, Godot specifically is free and open source, and you can modify it however you want. Other people have, so pretty much any time there's a shortcoming or like a feature it doesn't have, somebody else will add it, and then they'll probably just update the thing to have it anyway. So really useful stuff there. And stuff like buttons and health bars and widgets. And Godot also has its own specific programming language, which is really similar to C#, but it's a lot easier to learn. I know Unity uses C#. Do any of you guys use Unity?
I've dabbled in it. I haven't done anything serious.
Fair enough. Anyway, that's why I personally recommend Godot. Like I said, it's a good starting point. So, two really important concepts in game development in general, like planning-wise, is the asset pipeline and the development cycle. Essentially, when you create a file, like let's say a 3D model, let's say you want to make 10 enemies for your game. You want them to be like animated and have all this stuff and the sound effects and the voice lines and the physics and all that. You could work on them start to finish, one at a time, just move through, or you could do it like an assembly line. You could do each step on one model, each step on the next model, so on and so on. And if you've got a team of developers, you practically do have an assembly line where everybody is responsible for one step. That's how basically every AAA game works. You'll have like 2 guys who do specifically modeling, and then a UV guy, and then a texturing guy, and a rigging guy, and all that. Thing is, the difference between us and like a car factory is that you can always just go back and redo earlier steps. Not always. There's a lot of stuff that builds off itself, but like textures, you can just update that whenever you want. You want to add like more details, you want to add shit like something called a normal map, you can just do that. You can go back and add stuff all the time. A lot of things get tweaked, and people call that the development cycle, because it just goes in circles. You go back, you redo the parts you don't like, you move forward. So have my really fun diagram for that. So
Did you draw this yourself?
No, I got this done by a professional.
Oh, okay.
Where's your arrows on?
Yeah. So like, for any set of red dots, let's say that's a model, and I'm using something like a 2D animated game here, something like Silksong. This is not dissimilar to what they use. So you start with concept art, very important. Always use concept art. 2 minutes with like a pencil and paper will save you 30 minutes of programming or modeling or whatever else. If you do concept art, you would make a reference sheet to pass to a team of animators. You just use yourself, and that's like your standard, this is what the character looks like, a T-pose, basically. And then for specifically animating, you would do keyframes, then you would do all the frames between the keyframes. So like a keyframe, you would just draw the starting pose and the ending pose of any given motion. And say you put those 10 frames apart, and then you would draw like 8 frames in between. And usually the in-between frames are a lot shittier and worse drawing. So let's say you've gotten this far in the process and you say, hey, I want somebody to go back and redo all the in-betweens. That's the cycle, right? So you just go back and improve on what you had before. Usually the last step in anything like that is coloring, also shading, adding other stuff. Yeah, that's development pipeline, asset cycle. Forgot to mention, if you guys have any questions, just stop me. Yeah.
Isn't coloring normally done in concept art for like an idea of balancing, like you don't want too much of this color for characters and stuff like that?
Yeah, usually you decide what colors you want to do in the concept art, and that's usually part of the reference sheet, is like what part should be what color. But the actual keyframes, the animations, are usually just done in black and white, and then the color is added on top later by looking at the reference sheet. And we'll get into that. I've got a thing on 2D animation, not today or this week or anything, but later, if people want to see that. So yeah, your asset pipeline is a really good starting point. Knowing what you want to do and in what order can be very important. Sometimes you have really simple short asset pipelines that take like 5 minutes. Any of you guys play Vampire Survivors? Yeah, the enemies in that game could not have taken more than 5 minutes apiece. They don't move, they shift, you flip them over. They don't do much. So that's a really, really short asset pipeline, which is why there's like 90 different enemies in that game. They don't do shit. But if you want to say Half-Life 2, where you have a full guy and he's got, the motion, you've got the rigging, and he's got his own attack patterns and that takes fucking forever. That's a long asset pipeline by a much larger team. And the cool thing is, any type of asset or technique that you want to use, it usually takes like maybe 5 minutes of fucking doodling to figure out how to actually do something. So like rigging a mesh in Blender, you can just look up a tutorial for that. Knowing that you can rig a mesh in Blender in the first place, or even what that means in the first place, is the hard part, which is why I want to go into all that stuff. I'm not actually mentioning rigging today, but it is an example of something that is hard to learn about. Nobody explains this shit. At least I haven't found any good spots, like comprehensive spots to learn, which is exactly why I want to upload this to YouTube. So yeah, 2D assets, I figure this is a good place to start. I want to go through like the basic building blocks that you have to use for games. Most 2D assets are called sprites. I don't know where the term comes from. They all use PNG files almost exclusively. So if you don't know, your computer screen has a bunch of little pixels in it, and each of those have a little light in it, a red light, a green light, and a blue light, and it sets what level those lights are at. So all image formats just save the amount of red, green, and blue in each pixel. PNGs are special because they have a fourth value, which is called alpha, and it determines transparency. So like, this version of Mario is a PNG, and you can see the orange background behind him. This version is not a PNG. It's just got white background behind him. That's not actually a JPEG, I just covered it in white. It demonstrates my point.
Okay.
That is, if you took the same file and converted it from PNG to a JPEG, it would look like that. Or I think the background would actually be black if JPEG is. Anyway, point is, this is why you want to use PNGs. It's got transparency. Alpha is really useful. And alpha can be arranged. You can have like semi-transparent objects, no problem. Everything for animation, a sprite is a single image. Normally you have a hell of a lot of images involved. So this is a sprite sheet for Mario. And yeah, it's every single frame of the animation that a given character goes through. The reason sprite sheets specifically are used in games is because sometimes you want to like jump around or cancel parts of an animation. Like maybe Mario hits his head on something and you move from the jumping animation to the hitting his head animation, And so you usually jump around a lot more than you would in any traditional 2D animation. Like a movie, you just save frame by frame, like a GIF file. But you want a sprite sheet for games for that specifically. There's, again, a lot of tricks. So if Mario's facing the other way, you just flip the sprite left to right. Usually works, never many issues for that. Color palette. There's some crazy shit you can do with sprite sheets. Like even reducing the file size with space or colors. I don't know, there's a lot of fun tricks there. 3D assets get a lot more complicated really fast, unfortunately. 2D is just a lot faster to work in. But 3D modeling is altogether pretty simple. You've got any 3D model has faces, edges, and vertexes, and I'm just going to open up Blender real quick to demonstrate like what you want to do with a cube. So you can like extrude this face by a certain amount, click on buttons. You can do this and just build stuff that way. I can select a move tool and just shift this entire thing around, extrude it again. You can like inset, you can, where's loop cut? You can make like a cut here so that you have more stuff to grab. Cut right there, shift this whole thing up, and boom, I have a really fucked up church. Damn, that looks like shit. Anyway, we're gonna leave that up for a minute. Cool. So yeah. Next phrase, UV unwrapping. So now that I've got my model and it looks like something other than a fucked up church, the actual color and look of a model comes from a texture, which is just a 2D image that you apply. But in order to apply a 2D image to a 3D model, you need some sort of, well, you need a map, basically. What's called a UV map. Imagine unfolding every single face of your model like a cardboard box, and you get a UV map, which is a pretty great thing. You can also cut seams into models and everything so that it unwraps nicely. Blender has a lot of tools for that, which is why I left Blender open specifically so you can see however the hell this thing unwraps. So I go here. There's a lot of tabs in the top of Blender like this. I'm going to go to Object Mode, Edit Mode, Faces, and I'm going to hit UV Unwrap, and I'm going to say Smart UV. And it's going to work perfectly. See? Isn't that recognizable? And then I can select a specific face here, and I can see where that is over here. And now you can use this map to draw directly on the model. There's also texture painting, which is a lot more intuitive. It takes longer to set up. Point is, you have a lot of options in terms of that kind of thing. I'm not going to open up my phone. Yeah, it's not worth opening up my webcam again. All right. 3D assets, so for texturing, once you've unwrapped your model, you can use any 2D image you want as a texture. And you can do way more than just texturing. This is, out of everything I'm describing, this is the most like simplified step here. Paul knows what I'm talking about. But this does do a good job of explaining, you know, this is how you take a 2D image, this is how you apply it to a 3D model. That took me way too long to fucking learn. I don't know why. Maybe I should have looked up a better tutorial or something. But yeah, this is all you actually need to know. Everything, the actual shape of the model is called the mesh, and all the data pertaining to how it looks is called the material. And a material set lets you set way, way more than just colors or anything. Very, very handy. So yeah, shaders, another really, really important concept. One of the more important but actually less time-consuming things is called a shader, and I'd like to have something specific to talk about shaders. Any piece of code that runs on your GPU is what the shader is, technically. All a game engine really does is tell your GPU to run its default shaders. Game engines have a bunch of default shaders. You can mess with those a lot, and you can do some really, really crazy changes. Mostly, I just want you guys to be aware shaders are a thing that you can use that make games look radically fucking different. If you guys have installed shader, we have like a half dozen Minecraft modders in here, right? Yeah. So you guys have installed shaders for Minecraft. Yeah, you can make shaders for your own games, and just like Minecraft, it will radically change how it looks. And if you want to learn how shaders work, what?
Or like how Valheim uses shaders.
Right, Valheim does have really good fucking shaders. And yeah, almost all video game water is shaders. That's always fun. Sound effects. I'm not going to claim to be an expert in this because I'm kind of not. There's a lot of things I'm actually not. I should mention, I have 3 years of experience. I kind of wish there was somebody like more qualified who could teach this stuff. And I've talked to a couple like faculty members about it, and I don't know any. So I'm trying to teach this, and I'm sorry about that. Anyway, sound effects. What? Yeah. Anyway, so most sound effects are called Foley effects. I don't know if you guys have heard anything about that, but essentially old movies and shit, we realized that if you just record the actual audio of people like walking around and making footstep noises and whatnot, it sounds really fucking weird once you put it through a film camera. So they make footstep sound effects and shit themselves, and then they edit that back into the film. And games have to do that entire process by themselves anyways, because you can't fucking record what's happening in the video. You have to set all those noises yourself. Fun fact, the sound effects for Warthog and Halo 3 came from a Subaru, just a fucking Subaru, like the entire thing. It was the guy's mom's Subaru. Yeah, use .wav files. They're really good for compression, or rather you can kind of select how shitty your audio you want it to sound in return for disk size. Yeah, it's important to prevent sound clipping and all that. I recommend Audacity is easy software to use, or just download other people's sound effects, because unlike most other parts of game development, you kind of need like a good microphone if you want to make this stuff yourself. But other people have also made good stuff by themselves because they already own a microphone. So, yeah, the other thing, being copyright free is really important. That means you don't even have to put them in the credits or anything. Music. Music is really important, and I'm barely starting to learn about this stuff myself, but nothing will affect people's mood or the tone of any game you make more than music. Music is a massive, massive part of game design, and most of the most successful developers, at least people who work solo without a team, are musicians first and foremost. Any of you guys heard of Toho Games? There we go, here we go. Junya Oda, aka Zun, I don't even know if I'm fucking pronouncing that right. Anyway, great guy, degree in music, specifically made his games to show off his music. At least the first one. Because nobody was fucking hiring. He was like, okay, I'll make a game myself. Great guy, fucking legend. Yeah, .wav.mp3, speaking of Toho, over 90% music by disk space. That is true. You can actually look that up. He uses completely uncompressed audio files. Alright, this is the big one. So, scripts and scenes. Again, I mentioned how game engines are really important for how you put all of the ever files together in one big pot, and you do that for scene files. So Godot has like a .tscn file extension that shows you exactly what you, it just holds all your stuff in one place. This is an example of something. I was going to open this up earlier. So I had, what the fuck is it? Yeah, so just to open this up and demonstrate what I'm talking about with scenes being a collection of other assets. I've got an enemy scene somewhere in here once it opens. And this is, you've got this guy which controls what the hitbox is and how it moves. This defines the shape of the hitbox, and it's literally just a circle that you control the radius of. And the cool thing is that because this is a scene, elsewhere in the game I can just say, hey, spawn 20 enemies, and all of them will be affected by whatever changes I make here. So if I just adjust the size of this and run the game again, boom, now they all have bigger hitboxes. This just lets me drop in like a pathfinding segment. It's never one of those cool things that game engines handle for you. And this is the actual sprite image. So I've got a PNG somewhere in here. I could just say add node, sprite 2D, open it up, yada, yada, yada. This was a really stupid idea for a fucking project. But, so, yeah, that's why you want to use a game engine. Alright, sorry, we are getting close to done. That's all the technical stuff I wanted to talk about. Thank you. Fuck. Did I just close it? Oh my god.
What is your next?
So yeah, sorry if that was a lot. There is a lot to learn in game development. That is exactly why I like game development, because you never run out of shit to do. You never run out of new things to learn. Really, really fun. And if you don't like doing any individual part of that, if you say, man, I don't fucking care about drawing, I don't care about making music or any of that, you don't really have to. There's a lot of successful games that are successful because they cut out stuff that the artist didn't care about. I think a lot of games are great specifically because they're made the way people want to make them, because people have fun making them. It's an important quality of design. So, yeah, don't worry about stuff you don't feel like doing. If you don't feel like making stuff, just don't do that. And yeah, it might feel slow to learn, but 6 months from now, and this happens to me every 6 months, is you're going to look back and be like, damn, I learned a fucking lot. And I can do more stuff that I didn't realize I could do before. Anyway, I always think it's fun. Last section, art analysis. I promise this is important. Again, I'm not going to make you look at something and ask like, oh, how does this make you feel? But if you want to make video games, it's really, really important that you be able to analyze other people's video games. There's a Japanese proverb that I'm really fond of. The hand cannot grow faster than the eye. Essentially, your technical skills, your hand, cannot improve faster than your ability to see what other people are doing. It's basically, play more video games. That's the extent of that. And I'm completely 100% serious. If you want to make video games, play more video games, and it will make you a better game developer. Just having exposure to more techniques and options. So yeah, what is art analysis? You should be able to describe things deeper than just good or bad, because you might like something, you might dislike something, but that doesn't mean it's not useful to learn about. There's more useful questions to ask. So say, what elements do I like about this game? What elements stand out? Why did developers make it? How did they make it, and how can I make it myself? That's the really useful part of art analysis, is asking, how can I do this myself, and why would I want to? So there's a lot of easy, relatively simple ways to do that. Like, this is Factorio, and I really like how Factorio looks, and this is something I tried myself, and it's, okay, there's a really detailed industrial look, and it uses pre-rendered sprites. It makes really fucking complicated 3D models, and then it just takes a screenshot of them from far away, and then it uses those as 2D sprites. And so I say, okay, I should use 2D sprites. There's a lot of other examples of this kind of thing, like Rain World, never personal favorite, fully procedural animation, winds up looking really, really lifelike. So it's a useful thing to learn. Just look at how was Rain World made, I'm going to do something like that. Shaders, Return of the Obra Dinn, great game, really good atmosphere. Ever really good art analysis tool is Genre. When you say, oh, this game is a roguelike, this game's an immersive sim, or a fucking whatever else, a lot of people seem to think there's like a checklist of stuff that makes a game X, Y, or Z. In practice, that's not really how it works, because it's kind of impossible to define a specific checklist that makes a game X, Y, or Z. But genres do absolutely exist, and they all come from being inspired by what came before it. So, yeah, roguelike is anything that comes from the original game Rogue in 1980 that came up with a lot of different shit, and you can kind of map it out and see. So, like, Rogue inspires NetHack. NetHack is actually, like, a hell of a lot more famous and influential. That inspires stuff like Dwarf Fortress. But Dwarf Fortress is super fucking different from any modern roguelike. Like, it's got nothing in common with something like Dead Cells. But they're still roguelikes, they still come from Rogue. You've got modern ones like Cogmind. Who's mentioning Binding of Isaac? Was it? Yeah, Cecil. Also modern roguelike, and then Binding of Isaac inspired a bunch of other shit. Essentially, if you're playing games on, you know, this end of the map, look at games on this end of the map. See where other people got their ideas, and it'll help you. Again, like I said, play more video games. If you want to play specific video games, play games that inspired other games that you like. Yeah, that's all this slide says, actually. Yeah, play more video games. Pro tip. I know some of you guys have degrees to worry about, but you have more fun shit. Probably the single most important concept I can impart to you guys, don't try to make Grand Theft Auto 6 as part of your college club. I'm not saying it's impossible, just probably not that fun. Essentially, look at your project, ask yourself, you know, what do I actually want to make? What would I have fun making? You know, do I really need 10 music tracks or 10 different enemies or something? There's a lot of really, really excellent games that were made because they're very limited in scope. I pulled up Proverbs earlier. You know, that's not a very complicated thing to make, still a cool idea. Fucking Peggle, who here's played Peggle? Peggle is the shit. Anybody in here could probably make Peggle in under a week. So all you gotta have is a good idea. Yeah, and 2D is like 5 times faster developing than 3D in general. Also more limited. And if you want to make it look good, it's going to take even longer, but yeah. Yeah. Also, make games that you want to make. I know this is a general art analysis section. It might sound wishy-washy, but yeah, make stuff you want to make. Most of the best games, at least the ones I like, are made by people who really like making video games. And we don't have a budget or anything, which isn't great. But it's also a good thing. You can make whatever the fuck you want. If you're in college, you don't really have to worry about consequences for it. You don't have a job to worry about. Yeah, there's a lot of really, really good stuff that started as solo projects or even just club projects. You know, Black Myth Wukong was made by people who started out as a college club? Genuine. They had like a 30-person dev team, and 20 of them knew each other in college through a club, which is cool, and I would love to run a company someday. Let's see, what else?
Like, make your own design.
Yeah, it's not impossible. Concept art is your best friend. Like I said, 2 minutes with pencil and paper will save you 30 later. Plagiarism isn't really real in art. You can make whatever you want. Like, technically you can plagiarize, and some people are dicks with copyright, but like, again, we're a college club. Nobody is going to give a fuck if you just make Peggle. Rio, you have something?
It's another fun note on back on like you know, some games starting out in college. Another one that I'm pretty sure started out in college that I recently became big. Has anyone heard of the Modern Corporation?
Oh yeah.
Yeah, the
That
bottom.
one apparently started as a college group.
Really?
Yeah. It started with a group of college students trying to make a game, and then it got bigger.
Sick. I like Lobotomy Corporation. Yeah, start small. Play Dishonored from 2012. That is. Last year, that said watch the movie Aliens from '86. Changed my mind. So yeah, but do look to films in general. Games are, you've got audio, you've got visual, you've got gameplay. But if you want to learn how to use audios and visuals to really affect an audience, just watch movies. There's a lot of people, and they have a lot more experience than any game developer. And yeah, that's it. So thank you for thanks for listening, guys. Woo. And thank you for your patience with the microphone bullshit and the switching slides bullshit.